This is Algebra 1, Lesson 21A, the product rule for exponents, and example 21.1. So we're going to start with a little bit of review. We know what this expression means. 3 to the 5th means you have the factor of 3, that's your base, and it's going to be used a total of 5 times. That is your exponent. So it's going to be 3 times 3 times 3 times 3 times 3. That's what 3 to the 5th means. So what would this mean? 3 squared times 3 cubed. Well, let's write that out. That would mean 3. That would mean 3 times 3, and then times 3 times 3 times 3, which would still be equal to 3 to the 5th, right? So that's what this lesson is going to talk about, is being able to start with expressions like this and simplify them as a single product. Okay, here's another example. If I had 3 times 3 to the 4th, that's just 3 to the 1, 2, 3, 4, 5. 3 to the 5th as well. Okay? Now, there's a faster way of doing it, right? For this example that I did first, 3 squared times 3 cubed gave me 3 to the 5th. You should know that for the first one, there's going to be 2 3's being multiplied by each other. And for the second one, there's going to be 3 3's, which means I'm going to have a total of 5. So you can just add the 2 and the 3 exponents and know there's going to be 5. The same thing here. Here we knew there was going to be 1, right? And then here we knew there were going to be 4. So we can see that's going to be a total of 5 of them. The difference with this second example is there's no exponent here. So what exponent is there if they don't write it? Well, there's just 1. There's just 1 3 there. Okay, and we're going to apply that to these examples. So let's look at A. If I have x to the 5th times x to the 7th times x squared, I could write all those out. I would write 5 x's all multiplied by each other, 7 more all multiplied by each other, and then 2 more all multiplied by each other. So the shortcut would be, well, I know with all of them I'm multiplying x, because that's what the base is for all of them. So that's the only factor we have is x. And I can see that I've got 5 of them plus 7 more of them plus 2 more. So 5 plus 7 is 12 plus 2 is 14. I'm going to end up with 14 x's all being multiplied by each other. With B, my factor is 5. That's what all my bases are. And my exponents just tell me how many 5s there are. I've got 2, and then 3 more, and then 2 more. So that would be 2 plus 3, which is 5, plus that 2, which is 7. So I could simplify that and write that as 5 to the 7th. So it's helpful to be able to simplify these with this rule that we just learned. Let's look at another one. P to the 5th times p to the 12th. How many we're multiplying? P's, that's what the base is, right? All of these, the base is p. And how many do I have? I've got 5 p's and then 12 more, all being multiplied by each other. So that's p to the 17th. And then the last one here, all of these, the base is 4. So the base is still going to be 4. How many do I have? Well, 2 plus 3 is 5, plus 25 more would be 30. So that would be 4 to the 30th. Okay? That leads us to this rule, the product rule for exponents. If m and n are real numbers and x is not equal, that's what this means, right? X is not equal to 0, then x to the m times x to the n equals x to the m plus n. So all that means is when you have a base multiplied by something else with the same base, then as long as they're being multiplied and they're the same bases, your shortcut would be just to add those exponents to simplify it. So let's go back and look again. That's what we did, right? For here on D, we had the same base for all of those. It was 4. And we looked at our exponents and we just added them up. 2 plus 3 is 5, plus 25 gave us the 30. So that's what this rule means. It's just written in some algebraic language. All right, let's do example 21.1. Now, for this is all one big term. You don't see any plus or minus signs, okay? So don't think of this as we're adding. These are all being multiplied. It's one big term. What do I have? Well, I could write it out long ways. I'm going to do one like this, but you're not going to want to do this, okay? You're not going to want to do this. You see how I did that? I had 2 of them, I had 2 of them, I had 5 of them, and I had 3 of them. Okay, you're not going to want to write those out the long way, but you could. How many do I have total? I have 1, 2, 3, 4, 5, 6, 7. So that's going to be x to the 7th. And then here I have 2 plus those 3, which is 5. Now, couldn't we have done it a lot faster? The base of x has 2 and then 5 more. So that's where I got the 7. And then the base of y has 2 and then 3 more. And that's where I got the 5. So your final answer would be x to the 7th, y to the 5th.